Let's get going. Welcome to Salt Deconstructed. My name is Carson Anderson. I'm here from Domo. My GitHub is at Carsonoid. It's where you can find the source code for this presentation and all of my past presentations. They are free and open source. Make, distribute, do whatever you like with them. I also tweet occasionally at Carson_ops. Before I get into it, I want to say I have a ton of content for you today. In fact, I have so much that I know I will not get through it all in 45 minutes. I'm sorry. But I have a full-length, slower, unabridged version of the presentation that I'll give you a link to at the end. So if there's anything I skip or breeze by or I just speak too quickly, you have that video. Please use it and distribute it. It is the complete thing at a slower pace. Let's get into it. Salt Deconstructed. Why Salt Deconstructed? Why do I think I needed to make this presentation, and why do I think it's useful to you? I'm going to start by saying I love salt. You can do a ton of things with salt, and I mean a ton. The problem is, because there's so much you can do with salt, it can get very overwhelming. As soon as you think, oh, I know everything about salt, you find some more terms and some more concepts, and all these things get thrown at you at once, and it can make it overwhelming just to figure out what everything is and where it fits. So what I want to do is take salt and break it down for you, make it easy for you to digest and understand. And I'm going to do that by breaking salt into 5 layers. We'll cover each of the layers one at a time to help you understand the pieces of salt so you can understand the whole better. We're going to start by talking about the salt minion. I'm going to cover it just a little bit because you're going to run some more salt minions than anything else in your infrastructure, so I think we need to talk about it first. Then we're going to talk about the salt master, because once you've got a lot of minions, you need someone to manage the herd, and that is what the salt master does. Then we're going to talk about how the master communicates to the minion, and the minion communicates back. This is the transport layer. I want to really drive this home because understanding salt's transport layer helps you understand some of the nuances of salt and even kind of some security concerns if you're not doing things properly. After that, we're going to talk about the way you interact with your infrastructure via salt or salt itself in the scripts layer. And finally, the bulk of the presentation, where I will have to start skipping things, is where we talk about what you do with salt, the modules. And there are a lot of modules in salt. These are the x.ys of the salt world. You're using them all the time, I promise you, even if you don't know that you're using them. So like I said, we'll cover these one at a time, and I'll cover as much as I can in the time we have. Let's start with the minion. Like I said, I think we need to talk about the minion first because it is the heart of salt. It's the one you're going to run more than anything, and it's doing more than you think it is. So the salt minion runs directly on top of the operating system. It is a long-lived Python process, which means it has access to all the hardware and software information on your system. It can operate autonomously, which is another reason why I think it's the core of salt, because it doesn't even need a master. You can use a minion by itself. The minion also runs most of the modules. So when we start talking about the salt modules later, most of them are for minion consumption. Some for the master, some for both, but most of them are run by the minion. The minion, because it's on the operating system, can be the authority about metadata of the system you're on, and that is called grains data. I'm going to dig more into grains data when we talk about grains modules, but the minion is the authority on that metadata for the node. The minion also does all of the template rendering. So even if you've used Salt a lot, you may not know, the minion pulls down all your template and template files and data and does the rendering. Again, the master offloads as much as it can onto the minions. That's all I want to cover on that. When you do have a bunch of minions, eventually you're going to need a master, and it's the job of the salt minion to connect to the salt master. The master then has this channel back that we'll cover more in the transport layer. The master can send a request to the minion saying, hey, I want you to do this thing. The minion will run the module in the request, which may call other modules, which may call other modules, and we'll cover that in the modules section. It generates a response and sends it back to the master so it can display it to you. Again, I'm just doing this very briefly so we understand where the minion is. I don't want to cover it too much. So let's move on to the salt master. Now, the salt master becomes almost essential once you get to multiple minions. You can use a master with a single minion, you get some benefit, but it's really all about dealing with the herd, your entire infrastructure in one place. But before the master can deal with the herd, you need to establish trust and communication between the master and the minions. And I want to cover this in the trust and encryption section. Now, I'm going to do a disclaimer here. I'm going to talk about encryption. I'm not going to be 100% perfectly technically accurate with the encryption because it'll just drive you crazy. But it'll give you an idea of what we're doing here and how it works. So we've got our master, we've got a minion wants to connect. The first thing the minion does is generate a public and private key pair. It sends the public key to the master saying, hey, I want to connect to you. Once that key is accepted, and we'll cover how that happens later, but once that key is accepted, the master says, okay, let me take my public key, a symmetric encryption key, encrypt them both with your public key, and send that back to you. The minion now has a way to verify it's talking to the master it thinks it is, and securely communicate with that master. It then takes all that metadata it's the authority on, sends that to the salt master and says, okay, here's everything I can tell you about myself. The master then has this data store of the minion key that's accepted and all of the metadata about that minion. And this happens every single time a minion connects. That whole process over and over. And what happens is the master builds this big database of minion keys that's accepted and all the metadata about those minions, and you can start doing powerful things with that in Salt. The main thing you're going to do is do targeting. Now, targeting is something that you're doing all the time in Salt, whether you know it or not. It's just kind of implied. So every time I talk about targeting, I'm talking about a type and a term. So we take the canonical test.ping, the first thing you'll probably run in Salt. We are doing targeting here, even though we're not passing a flag. We're doing the default of ID globbing. Take those keys, find any of them, match a glob of star, and tell them to do a test.ping. You can also do more fancy things. You can take that metadata, because you know all the operating system information about every minion. You can say, find every minion that runs CentOS, and tell them to run this command that makes CentOS functional. There are a ton of different targeting systems that you can use in Salt. I don't have time to cover them all. If you're curious, there is very good documentation on targeting and how you break up your infrastructure and send specific jobs to specific nodes and say, you do this, you do that. Again, that's all I want to cover. The next thing the master is going to be responsible for is pillar data. Now, remember, the minion has grains data, which it's the authority on, and the master can determine data about a minion based on what it knows about that minion, and that is pillar data. And this is a good place for runtime configuration and secret data. So we've got our master and minion. When the minion wants it pillar, it sends all of its metadata, an updated version, to the master, saying, here's everything about me again, in case you forgot, and here I want to get my data back. Tell me what you can tell me about me. The master says, OK, well, let me look at your key and your metadata, and I'm going to determine what data to give back to you. And the main way you'll do this, there are other ways we'll cover in pillar modules, but the main way you do this, and the first thing you'll probably do, is with files. So you write this top file and say, every single line on this file is a targeting line with the type and description. And I'm going to find every place you match and give you the associated files. So you match this database file, and you match this SE Linux file. So I'm going to take all the ones you match and all of my pillar modules and give you a big data object of everything I can tell you about yourself. So the minion says, what can you tell me? The master does all of that, returns the data object. Now the minion has runtime configuration data. It's not the authority on, it just gets from the master. And that's all I want to talk about with the master. Again, I want to cover those lightly so you know where they fit, but they've been done to death. Let's move on to the cool stuff. Let's move on to the transport layer. Now the transport is all about how the Salt master and minion talk to each other. Before I get into it, I do have to say there are a few options with Salt transport. You can use raw TCP sockets. You can use 0MQ. You can even use this Salt-specific thing called rapid asynchronous event transport. I'm going to talk about 0MQ because it's the default, it's what you're probably using, and it's what all the other systems are kind of modeled after anyway. So this will all apply to 0MQ and maybe some of the others. So we've got our master and minion. I just want to focus on the processes right now. And it's very, very tempting when you draw this and start talking about this to do this, to draw a double-sided arrow and say master, minion, minion, master. They talk back and forth, done. But I don't think you should think about it or even draw it this way. I think you need to think about it in the more nuanced way that it really works. And that is two different channels. You have the master to the minion communication bus and the minion to the master communication bus. And I'm going to cover these each one at a time. They are core 0MQ concepts. The first one from master to minion is the pub sub or broadcast bus. The next bus from the minion to the master is the request reply or direct bus. So the broadcast bus, I equate this to an encrypted radio frequency. Yeah, you have to have the decryption code, but everyone tuned into that frequency with the code hears everything you say on the frequency, which is where some of the security things come in. So we've got a master, we've got a minion. Remember, the minion initiates all the connections. So when I do this arrow, this is just primary data flow. It is not the connection initialization. So the master initializes, and the minion hears any broadcasts over the radio. If you take the multiple minion scenario, the arrow kind of falls apart. And I want to drive home that this is a broadcast, and I want to drive this home so much that I'm not even going to use an arrow anymore. I'm going to switch to this weird shooting star mace-looking thing I invented. Because it has a directionality, but I want you to understand it is a broadcast, and you will never see anything but this arrow again. So we've got our master, and anything it says over that broadcast, anyone listening with the key can hear it. So everything sent over the broadcast bus is sent to all minions all the time. I'm going to drive this home. Even if you get clever and look in the docs and say, well, there's 0MQ message filtering, and I can target a minion exactly by ID, no, those are all still broadcast. So something like this is insecure. You're telling everybody what a password is, and only some people need to know. This is also insecure, targeting specific, saying, well, I'm just going to tell DB1. He's the only one that'll hear it, right? No, you're broadcasting. Or if you get more clever, say, I know pillars are a good place for secret, which they are. I'm going to put them in line on the salt command because they're good for secrets. No, that is insecure. These are all equally insecure. And if you're starting to get scared wondering what's safe, what's not, it's actually very, very simple to understand. Everything you put after the salt command gets sent to everybody all the time. So never put anything secret after the salt command. If you're wondering, well, where do I put secret things? How do I communicate secret data? That is what the next bus is for. The request reply bus, I equate this to a private one-to-one communication phone call between the master and the minion. So they can say whatever they want over that. They're securely communicating, and only the two of them are hearing that. So in this example, we've got the master talking to the minion. When the minion needs to talk back, it creates a connection to the master. This really makes more sense in the multi-minion scenario. So if the master sends a broadcast and every minion needs to respond, they each create a channel back one-to-one, and they can say whatever they want, and that's secure. This is where some performance comes in, because the master takes as much effort to broadcast to one as a million, but depending on the number of responses you receive at the same time, you might overwhelm the master, which is why there's a batch flag when you run salt commands. So that's it for that. Let's go over the whole thing from start to finish. I want to show you transport in action. So I'm going to run a very simple salt command. I'm going to tell a specific minion set a grain to a value. Nothing after the salt command is secret. This is safe. So we've got our master minion infrastructure. And remember, the master knows a bunch of things about every minion connected. And it knows a lot of grains. I'm only showing the ID because that's all I care about right now. Master looks at the data and says, well, based on everything I know about everyone connected, I expect exactly one response. And so it's going to hold a place and wait for one response. Once that response is finished and received, it's going to be done with the command. This is why sometimes, if the master can't be 100% sure how many responses to expect, it will err on the side of expecting more. And you'll see why that kind of causes the minion did not respond in time error. So it says, OK, now that I know how many responses to expect, let me craft a message. I'm going to put everything after the salt command on that bus. Put it on the bus, which is like sending it to everyone at the same time. Every single minion then examines, do I match the targeting in this command? No, drop it on the floor. So targeting happens twice, once on the master side and again per every single minion. The one that does match says, yes, that's me. I'm minion 3. Let me do what you want. I'm going to set a role to a DB. And I'm going to generate a response, call you back privately, and send you the answer. The master then says, I received all the responses I expected. Here's the results. I'm done. And that's kind of a good, gives you a good starter of how transport works in Salt. Let's move on to the scripts layer. These bottom two are the heaviest part, which is why I'm getting through most of it so quick. This is where we talk about how you deal with your infrastructure via Salt and Salt itself. And because I want to cover each of these one at a time, I'm going to break them into groups to make it easier for you to understand. These are my groupings, not Salt's, just making it easy for you. The first group is what I call the action group. These are commands you run to take action in your infrastructure via Salt, starting, of course, with the Salt command itself. I don't want to cover this too much because you're going to use it a lot. You've used it before. There's plenty of documentation. But essentially, Salt command runs on the master, talks to the master. It broadcasts messages. Minions return responses, come back to the Salt command. That's literally all I want to say. You've done this a bunch. The Salt call command is interesting, though, because if you're new to Salt, or even people that have used Salt for a while, it's very, very tempting to say Salt to Salt master, Salt call to Salt minion. This is what people want to think it is. But it's actually not. It's actually simpler. Salt call is a lightweight Salt minion. It can run without a minion process even running, which is why I want to point this out. You need no Salt minion in the background to run Salt call. The only difference is it starts up, doesn't listen over the radio broadcast, just does what it needs to do, and then dies. That's all it is. It is, by the way, when I said the minion was autonomous, I meant that Salt call acting as a minion was autonomous, even though you can run the minion on its own. So let's move on to Salt run. Salt run is kind of like Salt call in that it runs and it doesn't do any targeting data. You run Salt call in the master, and it runs on the master by definition, which makes Salt run the perfect place to do all of your administrative things that need access to your whole infrastructure or the master itself. Things like managing your infrastructure, doing orchestration, saying run this on these machines, then run that on these machines, and then do this, and make it all dependent on each other, kind of like stateful infrastructure. Or even do things like deal with Salt job cache, anything where you need master level access. And we'll come back to this in the runner modules. Next is Salt SSH. So Salt SSH is really cool. We've got this powerful infrastructure I've been talking about, and this is really performant and really powerful, but sometimes it's too much for you or it's not set up yet. You're saying, I don't want a whole agent running all the time. That's where Salt SSH comes in. The only requirement for Salt SSH when you run it on master is that the remote machine has SSH access and Python, same dependencies as Ansible. Salt SSH connects up to the SSH daemon, copies the code it needs down, runs it locally, and returns the results. Notice there's more overhead here because you have to copy code because it's not pre-installed. But you don't need a long-lived agent. Salt SSH is also very useful with Salt Cloud. So Salt Cloud, like you might guess, is all about dealing with public and private clouds. You run it on the master, you can spin up a bunch of things in the clouds, but one thing you'll spin up a lot of is VMs. It'll talk to the cloud, provision your machines, you've got a new machine. If you're like me and you're afraid or you don't want to use Salt Cloud because you don't want to maintain some golden image that is pre-configured to come into your infrastructure automatically, don't worry, you don't have to. The only thing that's required on the new machine is SSH access and Python, because Salt Cloud will leverage Salt SSH by default, go out to the machine and set up your agent and point it back so you don't have to worry. All you need is a machine that you can install the agent on. You don't have to maintain a special image. So that's it for the action group. Let's move on to the next group. This group is what I call the daemon group. These are processes you run to extend Salt in some way, starting with Salt API. So we've got this really powerful infrastructure I keep banging on about, and we want a third party to leverage some part of that. It's very, very tempting to give that third party SSH access to the master. And it would work, but do not do this. This is way too much access into your system, and it's not a very efficient system. You want to use something more evolved. You want Salt API. Salt API runs on the master, hooks up to the master, and then you use an HTTPS or WebSocket client to connect to the API. And the reason this is better we'll get into with authentication modules, but the API comes with very powerful authentication and authorization. So you poke exactly the minimum amount of access you need into your infrastructure through Salt API, and you don't give everyone the keys to the kingdom. So let's move on to Salt Proxy. Salt Proxy is all about dealing with devices that can't even run SSH, something really low level, like switches, routers, any sort of dumb device, even something as low level as serial access. If you can write code in Python to access it, you can do it with Salt Proxy. So we have some dumb device. We have salt proxy. It has all the code and knowledge it needs to talk to that device. We'll cover this more in proxy modules. But salt proxy runs on a minion, hooks up to the master, and the master doesn't even know the proxy is in the middle. It thinks it's talking to this device like it's a full-fledged minion in your infrastructure. And you can hook it into orchestration and all of that stuff. So that's salt proxy. Next is salt syndic. Syndic is short for syndication. It's all about dealing with multiple tiers of master minion infrastructure. So we've got our minions, and we've got our master hooked up, and this is great. But a lot of times you end up running multiple tiers of infrastructure because of geographical separations, lag, all of that. And you still want a master of masters at the top. You want to run one salt command, get all your results in one place. That's where salt syndic comes in. Salt syndic runs on the lower tier master, hooks up to the upper, hooks up to the lower, and proxies traffic between the two for you. In fact, if you dig in, it is just a dumb proxy between. It's taking radio from above, sending it down, phone calls from below, sending them up, just proxying traffic. It's very simple. You run it on all the lower tier masters, and it allows you to run a single salt command at the top. And just like with salt proxy, the top master doesn't even know the middle masters are there. It thinks it's talking directly to the minions. By the way, this is where I want to interject and talk about SaltStack Enterprise for just a second, because it does work essentially the same way as salt syndic. It is an agent you run on top of your existing infrastructure that gives you this kind of powerful single point of access, but it comes with more powerful kind of GUIs and RBAC and all these other tools that you can get in the open source, but it's kind of a more cohesive experience. That's all I want to say about SaltStack Enterprise. So let's move on to the next group. The next group is what I call the utility group. These are tools used to take action in Salt itself, starting with Salt Key. Now, Salt Key is all about dealing with that key authentication we talked about earlier. Remember, the minion sent its public key saying, I want to connect. The master has a key cache saying who's connected, who hasn't, who's allowed in, who's not. Somebody's got to accept that, and that's the job primarily of Salt Key, although there are other ways to do it. You run Salt Key on the master, you can list keys in the cache, you accept keys, or delete, etc., bring them into the fold. That's really all Salt Keys are for, is to help you manage that key cache. Next is Salt Copy. Salt Copy is also very simple. So you've got a master, you've got a minion, you've got files on the master, you need to get to a minion or minions, and you can do that by writing states and all of that other stuff, but sometimes you want to do it in an ad hoc way. And that's what Salt Copy is for. You run Salt Copy on the master, and it can copy files to minions. In fact, it is just a wrapper around the Salt command. There's nothing you can do with Salt Copy that you can't do with the normal Salt command. The syntax is just a lot cleaner and simpler with Salt Copy. So it's there for you. Next is SPM. SPM is interesting because it's short for Salt Package Manager. It's also the only one in here that doesn't start with the word salt outright, which is interesting. And it's all about dealing with formulas. And if you're new to Salt, a formula is very simple. It is a tarball of state data and optionally some default configuration data. That's all it is. The problem with formulas has never been availability. There are hundreds of them in the Salt GitHub. The problem has been using them, especially if you've got multiple masters, because every time you've wanted to use a formula in the past, you have to go reconfigure all your masters and point it at the Git, or clone it locally and point it at the local clone, and it's kind of hard to manage. So we said, hey, we know how to put tarballs on systems. It's called a package manager. So you put Salt Package Manager on the master. You configure it once, saying, here's your repository. It can go out and list packages, formulas in the repository, install, update, delete them with a command, and you never have to reconfigure your masters. I think once this really evolves with the deep dependencies and some other things, it's going to be incredibly useful. It's probably how we distribute formulas in the future. So next is Salt Extend. You'll understand why you want to use Salt Extend when I get done with the modules, because every single module in Salt can be customized. And Salt Extend's job is to help you write perfect boilerplated code for custom modules. So I will say it's a little harder to use than I wish it was. You have to have a few things set up first. You have to have Salt Minion or master installed. You have to have the Git repo cloned, and you have to be in the Git repo, because it uses both libraries and local files. Once you do that, you can run Salt Extend. And if you give it no flags, it'll ask you some questions. What type of module are you extending? What's the name? What's the description? You answer the questions. It spits out perfectly boilerplated code. You don't have to go to GitHub, copy an existing one, and change it. Just let it template out something for you. I think this is very useful. Finally, and the simplest one is Salt Unity. It's very, very simple. It's just a wrap around every other Salt command. It's really all it is. It takes individual commands like Salt Master and Salt Key, replaces them with Salt Unity and something else. The main reason I can think of that this exists is to make your pseudoers files easier. So you add one thing and never have to worry about all the different scripts they might be executing. That's it for the script section. Let's move on to modules. This is the bulk of the presentation, and where I'm going to have to start skipping some stuff in the name of time. So modules, every time I talk about module, I'm going to give you three things. I'm going to give you a type, a name, and a function. Type is something like execution module. I'm going to show it in this kind of chemical symbol box. Name is something like command, and function is something like run. So as an example, we'd have an execution module command.run. And I'm going to show it to you like this every single time, because they all follow this pattern. So there are a lot of module types in Salt, and I mean a lot. There are so many, I forget how many times to click here. There are a ton of module types. You can extend them all, and they can all kind of leverage each other, and it's very powerful. And I'm going to explain as many of them as I can in the time that I have. To make this easier, I'm going to break these into groups so that, again, my groupings, it's easy for you to understand, cover them one at a time. We're going to start with the core module group. Then we'll move on to the data, the event, the result, admin, integration, and utility. And we'll come back to this list in a second. Again, I'm just grouping them for you. Also, every time I show you a module, I'm going to give you 3 bits of data. I'm going to give you the place in the repo that you go to find existing ones, because it's very useful to reference them. The place you typically put it on the master to sync, although that's customizable, and the command you run to sync them to the minions. Because remember, most modules are for minions, so you have to get them from the master to the minion. I'm not going to be able to point this out in the name of time, but it's there with everything, and it's there in the full video. I point them out, every single one of them. So because it's a deconstruction, let's take the modules layer, and let's deconstruct it further into those groups that I gave you and cover them one at a time, starting with the core module group. Now, the core module groups are the modules you are using every day if you use Salt. I promise you just may not know that's what it is. Starting with execution modules. I will point out that execution modules are interesting because they're the only ones that don't follow a pretty static pattern. They are the original canonical modules of Salt. That's why they're at /modules. After this, you'll see the pattern and pick it up pretty quickly. But execution modules are the things that come after a Salt or Salt call invocation. You've seen these all before. Notice the verbiage. They are do this thing now, get.clone, command.run, do this thing. No implied question. You're always going to do it. So again, you've used these a lot. They've been done to death. I don't need to cover this. These are what come after Salt and Salt call. I do want to take a second and point out, you can take any Salt or Salt call invocation, highlight portions of it, and see where it maps to, the exact file in the code that it maps to, the function args and keyword args. And this is so direct that you can even go, that the documentation is just the function declarations of the code. Like, it's very, very easy to understand and reference these and dig into the code. Again, if you go look at the full version, I can stay on that a bit longer. Next are state modules. State modules are, the last time I'll point out this information because it establishes the pattern. It's salt/module type, underscore module type. It's very, very obvious. State modules are another thing you're using all the time. You'll see them in the state files you're writing. So notice the verbiage here has changed. Packets installed, service running, get cloned. They've changed to implied questions because there are do this, if not, make it happen. So I'm not going to go over this too much, but you could do a package.installed, write a simple state, say, is the package installed? No, make it so. Or you could do a service running, is it? No, make it so. Again, there's a lot of stuff on this. I don't want to spend too much time. But again, you can take a state declaration, highlight portions of it, find the file, function args, and keyword args, and there are even a couple different ways to do this. I think this is very useful for digging in and seeing exactly what your modules are doing if you're that curious. And I am. Finally, I want to talk about how these work together because they have an interesting relationship that I think is worthwhile to point out. So we've got a typical state module, get.cloned. Make sure Git repo is cloned in a certain state in a certain place. Like you might guess, the first thing you have to do is find out, is it cloned? And there is an execution module where you can check the status of a Git repo into place. And instead of rewriting that code, get.cloned leverages the get.status execution module. That way you can use it directly and other modules get to use it. If you dig in, they actually use a ton of other modules. This is very, very normal pattern, state modules using execution modules. Write the code once, use it everywhere. In fact, if you dig into the get.status, you'll find it uses a bunch of other execution modules that aren't even Git modules. Again, modules calling modules calling modules. You can build these trees all day. Write the code once for anything you want to do, and then just reuse it. So that's it for the core modules. Let's move on to the data modules. I said I'd come back to these. Data modules are all about getting runtime, secret, and configuration data. Let's cover them one at a time, starting with grains. Now remember, the minion is the authority on grains data. That's data the minion can tell you about itself. And there are lots of ways to do this. You can get the core hardware operating system information. You can call out to disk arrays. You can call out to cloud metadata. I'm always giving you 3 examples here, by the way, but there are, depending on the module type, sometimes hundreds of different modules already there for you to use. So of course you can hard code data, and there are some built-in grains that you get, but sometimes it's more useful to leverage some external system. Say, well, call out to mdadmin, tell me what my disk arrays are, return the results. The minion will call every data module, or every grains module you've configured, compact all the results into one, and that is that big grains data object that it sends to the master. It's just the result of all these individual module executions. Next, we're going to talk about pillar data. Now, pillar data is primarily for master consumption because the master is the authority on pillars. So these are things like talking to MySQL, libvirt, or even external commands. Anything where you want the master to be the only one that has access to whatever system you're querying, and you want the master to be the authority so that nobody can lie about it. So of course, you can do the pillar thing that we talked about earlier with config files, but static config files are not always the best. So you can run any number of external pillar modules you need. When the minion says, what is the metadata about me? The master says, let me consult all my sources, combine that all up into one, and tell you. We use this to talk to the Amazon cloud to get tag information, because I don't want every minion to have keys to the Amazon cloud to describe their own instance. So that's grains and pillar. The minion and master are the authority there. The last one, SDB modules, is for when you want neither the minion nor the master to be the authority. SDB is short for simple database module. Not secret, although it is used for secrets a lot. It's actually short for simple database modules. And like I said, these are all about dealing with external systems that are the authority on some piece of information. Notably here is Vault. So as an example, I've got a Salt minion. It's configured to use the SDB module for Vault, which means it talks to Vault to get, set, and delete data. Notice what's not here, the master. The master's not here, which means that that whole trust encryption thing we set up is gone. It's up to the third-party system to figure out how it does its own trust and encryption and determine who gets what data. But it's very useful for external systems. It's also very useful because, like any other module, you can call them directly. Do not import the Vault code into your custom module. Use the Vault SDB module yourself. By the way, the reason this was even written, and one of the main use cases is for Salt Cloud. Remember, Salt Cloud calls out to the machines via SSH, which means it needs credentials. And I don't want to hard code those. That's scary. So what I can do is replace them in this kind of URI salt syntax saying, go to the SDB module this machine has configured as REST and get the cloud user and cloud password values and replace them here. It's a simple inline string replace, which is why it's simple database modules. So that's it. Before I go, I want to give you a second to look at these. This is kind of general community guidelines, my opinion, on when things should be used. The one thing I want to really stress and point out here, grains are not on the secret row. Do not use grains to hold secrets. Do not use grains to provide secrets. Minions can lie about their grains. They're the authority. So if you make a role of user, it's really easy for someone that hacks that machine and has root access to say, well, let me try role of admin and see what secret data I get back. So never use grains for secrets or to provide secrets. That's what pillars and SDB is for. Next, let's move on to the event modules. Event modules are where you take your Salt game to the next level. This is where you go from just kind of using Salt to Salt really managing your infrastructure for you. Starting with beacon modules. These are the event modules that generate events in Salt. So these are things like iNotify, disk usage, service events. There's lots of systems that watch your minion and send out when things happen. So as an example, we've got a minion that's got all three of those configured. It has a file that you wanted to watch that gets created. It sends an event saying, hey, you want to know, file got created. Disk starts filling up. It sends an event saying, hey, you wanted to know, this disk is filling up. Service dies. It says, hey, you want to know, service died. The beacons have gone out. The beacons have been lit. And we know that this minion calls for aid. But of course, calling for aid is no good if somebody doesn't answer. And that's why I inject reactors. Notice they're not the same shape because they are not a module type. But they are probably the first thing, not the only thing, but the first thing you'll do with events. Reactors are very, very simple, and they work well with events. So they are, one, a reaction, a thing to do. In this case, the reaction is clean up some temp files. Then there is a list of when to trigger each reaction based on the events you receive. So in this case, we're saying, hey, if you get the temp disk full event, trigger the clean temp reaction. These two files are everything you need to do a reactor. And that can be the master or the minion, by the way. So we got our Salt master, we got our Salt minion. You have those files on the master. When the minion has an event, disk getting full, beacon out. Master receives that, says, oh yeah, it's calling for aid. What am I supposed to do again when it calls for aid? That's right, I'm supposed to send a command back that says, clean up your temp disk then. This is a contrived, trivial example, but it's like paying somebody to watch your infrastructure for a certain thing and run the Salt commands or other reactions to solve it. This is self-managing, self-healing infrastructure. My favorite planned use of this, by the way, is to kind of take this to the nth degree. When a minion's disk starts to fill up, have the master call out to the cloud, grow the disk online. Call out to the minion, grow the disk online. Call out to chat and events or alerts and say, this just happened. I averted disaster for now, but you should go check it out. Because I can't always know where to clean up files, but it's pretty easy to pay a few bucks to grow your disk online and save a catastrophe. So we'll move on next. Queue also is really, really useful when you start dealing with a lot of events. So queue modules are all about dealing with databases to house events. So as an example, we have a Postgres database that holds our infrastructure events. You can run the insert method of the queue module and insert events on there. And minions can do this. Other systems can do this. The cool part is that the cloud, or an agent running on behalf of the cloud, can run this and put events on. Even though it's not a minion, it can stick events into your infrastructure saying things just spun up, things just got shut down. Then the master or another system can use the pop function and pull the events off at its leisure. Makes it useful for sharing events with multiple masters or not dropping events if the master's not running when an event happens. So we'll kind of come back to this in a second. Next, I want to talk about engines. Now, engines are a lot of things. They are, interestingly, the place where ChatOps lives in Salt. So you notice we've got Slack, we've got logging here, we've even got webhooks. But as an example, this is where ChatOps lives. And an engine is very simple. If you've got a master and minion and you need to run some extra Python process to do something in your infrastructure, do not spin it off and manage it yourself. An engine is a long-lived Python process that can run on either the master or the minion. In fact, you can run multiples. And it's great because the Salt master and Salt minion processes manage that for you. If they go down, they restart them, and they inject some extra variables to make it easier to interact with Salt. So like I said, engines are always running, which makes them really useful for doing things like reading off events, because they can listen to the event queue and say, hey, this event happened. Let me call it to your chat and tell you, hey, I got an event that the disk just got full on this minion. Or vice versa, you can say, hey, I want to read from chat. When I get this command from chat, the engine will read it, run the command in your infrastructure, and it's just like going on and running the command. There are lots of different things you can do with events. One of the other things you can do with events is we've got this queue database from before. The engines, of course, have access to all of the queue modules. So they can pop events off and put events on the queue so they work separate. If you want to do something other than normal master reactions, engines are a good place for that. I'm not going to talk about Thorium too much. Thorium is interesting. It is about events, but it's not super well supported. I'm not even going to cover the examples here. Basically, the canonical use of Thorium is what do you do when the minion goes down? There's no event for a non-event. So the canonical Thorium config is this. And it says, hey, if a minion doesn't ping back in time, remove it. And the syntax is a little hairy to understand. Basically, I would say if you are trying to do something with events and you can't do it with reactors or an engine, maybe Thorium is what you need, but I don't want to spend any more time covering it here. So let's move on to the result modules. Result modules are all about dealing with the result of salt and salt call and even salt run commands. And they're about either the command line or other systems. So starting with output modules. Output modules are things like the default outputter or JSON or even having a pony say the results of what just happened. These are different ways you want to format and display data for use on the command line. So we run a salt or salt call, and it generates this big blob of what happened. And you want to display that in a lot of different ways. You run it through an outputter module, whether by default or you specify. That formats it in a specific way. So as an example, we have the default one if you don't specify, of that high state outputter, which is that nice tabulated, color-coded output that you see all the time in Salt. Or you can do dash dash out to JSON so you can parse it in another system. Or you can, like I said, do dash dash out and have a pony say the results. And I was curious, and this is what it looks like if the pony says the results. It's a fork of the Debian Cowsay project, but it makes ponies. So that is in upstream Salt, by the way. You don't even have to install it, like in Salt right now. Next are returner modules. Returner modules are also about dealing with command executions, but they're about dealing with sending them to external systems. Things like MySQL, Kafka, Couchbase, all these kind of places where you want to send all your executions up, aggregate, and report on them, not lose them when you close your command line. So as an example, we've got our salt command with a big blob. That gets sent as well to output as returner modules, which can go to an external system. So you can tell a minion to, by default, send everything to a specific module. Or, by default, send everything to 2 or 3 modules so that you can do different kinds of processing on the results. Or you can override it ad hoc on the command line saying, just this result, send it here for storage or analyzing. So that's all I want to say about the modules. I will take a second and say that, of course, you can use them together. So if you've got your salt or a salt call, you can send it to both an outputter and returner or multiple returners. They're not mutually exclusive. Let's move on to the admin modules. I'm going to kind of skip the wheel module here. Wheel module is all about dealing, it's kind of mostly useful for internal Salt stuff. The main thing I want to point out is how it's reused in Salt. So we've got our key.accept. We've got our key module in the accept function. That's used, of course, by Salt key. It also can be used directly by Salt API, and it's almost trivial to use that in your own script, like an engine. You can import that library and use it. So if the normal key acceptance isn't working for you, this is really, really easy to take this library and just use it on your own. That's the only thing I wanted to say about wheel modules. I do want to talk about runner modules because, like execution modules, they are the thing that backs Salt Run. They're the next thing that comes after a Salt Run invocation. So they are all about doing the things that Salt Run does. Again, things that need master level access. So when you run runner modules, they run on the master by definition with full master level access. And you can do that with Salt Run for sure. You can also call runner modules directly via Salt API with the special syntax saying, run this runner module. You'll never even give it targeting information because it runs on the master by design. So you can do all these administrative things. This is a great way to provide access into your system through the API. Let's move on to the integration modules. This is where we're finally coming back to the Salt API like I promised, starting with the authentication modules. Authentication modules are required by Salt API. If you're going to use Salt API, you need to do some sort of authentication into the system first. And they are things like the default Linux auth or MySQL or LDAP, all the different auth systems you can think of. And what you do is you go to the external config and say, here are all the auth modules I want to do and all the ACLs for each module. As an example, I'm saying, hey, if the Carson user authenticates via PAM, he can do anything he wants. Some scary root command, he's a smart guy, we trust him to touch all of our infrastructure. But sometimes you want to lock this down a bit more. So as an example here, we've got LDAP saying anyone in the DBA group can do exactly what they need. So as an example, they can just target exactly RollDB machines, run exactly this function on exactly these arguments. Very, very narrowly scoped just what they need. One final example, we have our MySQL API user who can only do list things. He can't even take action. He can just use Salt to inspect the infrastructure and get what he needs back. You can, by the way, use all of them simultaneously. They're not mutually exclusive as well. And I've been showing one example of a user and group in each of these, but you can have as many users and groups per module as you want. So let's move on to the Net API modules. Net API modules are the other half of the Salt API. You have to run at least one Net API module to get Salt API up. Examples of these are Tornado, CherryPie, and WSGI. These are, by the way, the only case where there are exactly 3 of these out there. CherryPy is a REST API. The other two are kinds of WebSocket APIs. So we've got Salt API talking to the master. We need some access into it, and you have to run at least one API module. Maybe it's Cherry API to get RESTful access. But what's cool is you could run all of them simultaneously if you want, because some users may want REST and some may want WebSockets, and you can provide both. They, again, are not mutually exclusive. So between our API module, our authentication module, we can kind of control, saying you can run exactly this or exactly that. And this bottom line is my favorite example of this. Let's take and wrap, I always do this. I write an execution module, wrap a scary thing in a known controlled thing. So here, we're doing an rm-rf on a database machine. And that's scary as all get out. I don't want to give anyone access to that. But what I do want to give them access to is to run exactly the DB wrapper module and the cleanup function. I know exactly what they're doing, what they can do, what they can change, what they can't, and I can even abstract it. If I change what a cleanup is later, they don't have to change what they're calling. They just call out. So you combine that with authentication, saying, hey, API user can do DB wrapper on DB machines. This gives me really tightly controlled, abstracted away, but still very powerful infrastructure access. Next, we're going to talk about proxy modules. Proxy modules are all about dealing with those dumb devices. They are the backing of Salt Proxy, like I said. You have to run at least one proxy module with Salt Proxy to get access to your infrastructure. So these are things like switches, routers, smart lights. Taking as an example of that, we know we have our device here from before, and we know that the master sees it like this. It thinks it's just talking directly to this dumb device. In this case, we're going to run the Philips Hue module, which can control smart lights for us. And because Salt Proxy is really smart, it can have an ID like a minion. It can even have grains like a minion, which means you can do stuff like this. You can do a Salt invocation or Salt API or orchestration or anything that else, because it's just like a minion in your infrastructure. Saying, hey, this minion, run this thing. Set your color to red. The build just failed. You can hook this in the API, all the other systems. It's very, very powerful to control everything with Salt. We'll cover cloud modules, and I'll skip the next one. So cloud modules are the backing of Salt Cloud. These are basically, there are already cloud modules for every public and private cloud you can think of, and they're all about spinning up machines. Very, very quickly, for Salt Cloud, you essentially create a configuration file that says, here are the types of machines you can create, here's how many copies I want, and you use the cloud module to both read the config and talk to the cloud, saying, hey, is this true? If not, make it so. And you can change it, and it will make sure, again, your infrastructure is stateful. I'm going to skip the rest so we can get to some utility modules before we're out of time. Again, anything I'm skipping or that you missed, the full video link is at the end, and I go slower and you can cover everything. So let's move on to the utility modules. I want to cover a few of these here, starting with serializer modules. We all kind of know what serializers are if we've done any sort of coding, but I want to point out the modules because their usage is interesting. So serializer modules are all about serializing and deserializing data. Like, that makes a lot of sense. And these are all the different kind of serializers that you think of. The cool part about it is, so you have your serialized data, you use a serialize function, serializes it for storage or transmission, deserializes it, puts it back into memory. This isn't new. What is cool is how you use it in other modules. Remember, modules can call modules. So we take the file.serializeState module, and you can write a configuration that says, hey, put this data as JSON, and whatever you put after the formatter is any serializer module you've installed. So you don't have to, again, worry about importing libraries. It just has full access to all of those modules. It's also very easy to use in your own custom module. So if you're writing a custom module and you need to serialize some data, do not import the libraries yourself. You do not need to. As an example, here's a state module that ensures the configuration, and it deserializes message pack data. And I don't have to worry what library I'm using on the operating system. I just use the function that's already injected for me via this kind of special injected dictionary here. So I'm going to skip executors because they're a little esoteric. And we will go on to rosters, and then I think we'll go to the credits. So Salt roster modules I want to point out because they are what back Salt SSH. And if you're going to use Salt SSH, you need to understand them to a degree. I also want to point them out because the Salt SSH knows how to read Ansible config files directly to get lists of nodes you can talk to. So again, another reason if you're trying to switch, like, you don't have to use a different config, at least to list the minions available to you. So remember, Salt SSH is agentless. It means there is no list of all the minions connected. So who tells you who you can talk to? That is the job of a roster module. A roster module calls out to some external system, even if it's just a flat config file, returns the results and say, here are all of the minions you can talk to and everything about them, again, because you have no agent. So that's it for this. Let's go on. We have about 3 minutes left. I'm going to move on to the credits here. So I want to thank all the logos I used are properties of the respective companies. I thank everyone on OpenClipArt that I took art from, because I use it quite liberally. The presentation software I use is Sozi. I think this is really cool software. You make a SVG, use Sozi to edit it, and it spits out just an HTML file, and you use that, and it's just a website you can serve. Finally, this has been Salt Deconstructed. Here are all of the links that I promised you. Again, this is the full video, also the slides, so I go a bit slower, cover everything in kind of more detail. It's about twice as long. And if you like the presentation and the style of presentation, then please go look up Cube Deconstructed, which is where I do the same thing to Kubernetes. And I think that was a really cool presentation as well. Again, here's my information if you want to contact me, and that's it. So I did save about 5 minutes for questions, it looks like. Or I can go back and just start covering stuff that I skipped. I just wanted to make sure we had time at the end for questions. I'm going to go back. Why not? No one has any questions. Let's go talk about stuff. I'll talk all day. Yeah? Sorry, say that again? Renderers. Yeah, I would love to go through renderers. I need to go back with this because it's a different web page. Okay, renderer modules are very cool. Okay, so renderer modules. Renderer modules, if you don't know, are basically what you use whenever you write state or configuration files, and there are a ton of them in Salt. So I'm going to actually go back. Let's go start. So these are things like Jinja, Mako, or even raw Python. And you can use these both to make configuration files and to render your state data. So as an example, you've got a very, very typical Salt state you might write. And you know this is a template, and we all, if you've used Salt at all, you'll know that this is Jinja. Jumping cow. There we go. Thank you, screensavers. What you don't know is you can do a hashbang at the top and override the renderer for any state or configuration file, well, state file. Say instead of running the normal Jinja, I want you to actually send it through Python, which is just going to have this function declaration, so I can do really complex, like hard logic. Because if you've ever done a lot of really complex Jinja, the logic gets really hairy really fast if you're doing too much than just a few for loops. So you can actually shell out to Python or any renderer. Jeez. You can also pipe renders into other renderers. And in fact, this is the default. If you don't specify a renderer, the default isn't just Jinja. It's actually Jinja piped into YAML, and you can specify as many of those as you want. It's like kind of like doing a shell bash pipe from one thing to another to another. So that was, I don't know why it's doing that. Anyway, so that's renderers. I think you can also, if you're doing a specific configuration file in like a file.managed, you can specify any of the renderer modules that you want as well in there, and they'll work pretty much the same way. So let me go back so you guys have that link one more time. I think this is why I don't go off script. Okay. So there you go. Another question where I won't actually change the slides. Thorium? Yeah, so Thorium is interesting. It's out there. It's fully released. But for some reason, they... Thorium is 100%. Everything I talked about here, the only thing that wasn't open source was SaltStack Enterprise. Every single thing else I talk about is in the open source and in the community. You kind of heard in the keynote that they're very, very proud of their open source community. And they spend a lot of time going over that. And they kind of put everything in the open source community first and then use it in enterprise, I think, which is really, really, really smart, because as soon as you start forking stuff, you start kind of making worse versions of your products. And I have no idea why. I'm glad it just started doing that now. Anybody else? I'm just going to do this. Technology. Okay. Like I said, I'll get those versions of the links one more time, because like I said, that is about twice as long as my other version of the presentation. I guess I had a little more time than I thought. That's it? Yeah.